Okay, I'm back, I hope. I don't know, I have strange, weird problems with that OBS tells me that it got reconnected, and I don't know what to do with it. I searched some of the forums and I don't know what can be problem with. So I know we will just try to continue if like in couple of minutes, 5-10 minutes, I don't know, it will reconnect again. I would stop until I fix this shit forever. So we stopped previous time on for those who don't know, we're at Microsoft Office right now, Sundays evening. We are solving leetcode problems. I'm refreshing my knowledge about the leetcode. You can see previous stream, I think, to catch up what we are doing here right now. We just stopped on this problem. We solved it, and we're gonna analyze the space and time complexity here. So basically, regarding the time complexity, we see that we're iterating over string 2 times with the for loop, right? And which give us of 2 times n, where n is length of s. We are twice iterating over it, and this is like the time complexity due to this reason. Now space complexity. This vowels hash set has constant length, so we don't care. I don't know, should we include the moving from string to characters array as our space and time complexity? I actually ignored it because it will be also n. Every time we are doing it, it's n space complexity and n time complexity, because string is immutable. This is a JavaScript limitation, or like not limitation, but kind of benefit. So it means that we cannot modify the string in place, right? And that's why we move to characters array, and it creates new array for characters with the length of n, and it pulls the letters or characters from the string to this characters array, which give us O of n space and time complexity. Other than that, we are maintaining array vowels, which in worst case can be also n, and that's basically it. The output we are modifying in place and just returning. So space complexity will be also O of m, and this gives us O of m as well. So these are kind of easy problems. Stream hasn't disconnected yet, which is like I'm very happy with this right now. Let's see, guys. Let's go and try next question. Reverse words in string. So this problem is actually much better, much interesting. Okay, let's start it. Okay. Stream seems like going all right. Good. I hope it will stay like this. I hope. Let's see. So, how are we gonna approach this problem? We are given a string, and word is defined here as sequence no space characters. So clearly it's D, sky is blue. These are 4 words in this string, and we need what we should do. We actually should get these words, reverse the order of the words, and put it back divided by single space, these words in the reverse order. So basically in this case, hello world, we're returning world hello without extra spaces, whenever they are. So let's actually let's actually go and try to think about it as like brute force or naive approach or whatever it is. We can actually traverse all the string, all the array, right? Meanwhile we can skip all the spaces and just collect the words into some array. So after traversing this string, we will have array with the word hello and word world. And after that, we can iterate over this array of words from the end to the start and just put word by word with one space and return this string. Let's implement this approach, and we can there is follow-up for this, right? To do it in constant space. We will do it as well, but now let's try to do it as like our naive simple approach. Good. So first of all, what we need to do, we have to keep some array of words, right? Let's choose this one. Then we want to iterate at index equals 0 while index as links. So how should we do it? Whenever we are encountering empty space, so basically this character, we are just skipping it because we are not interested in spaces, right? We are interested to collect the words, which means this continuous characters block. So okay, at this point we skipped all empty spaces right here, and if we reach to the end of the string at this moment, so if index equals to s length, then we just break the array, because if we traversed up to the end of the string and we didn't reach any word, it means we are done. We will have no more words and we can proceed with the latter behavior. Now at this point, since we got index plus plus and index is not less than length anymore, or we encountered the non-empty character, now we're gonna again iterate up until we again reach this empty character, because now our index is pointing to some character, some letter, and we want to kind of collect and accumulate these letters. And when we accumulated them, this is kind of our words. So let's say we are right now at index s. We want to iterate to k to y, and when we encounter an empty space here, we know that this is the word, and we want to put it to our array. So while index is s length and our i index is not equal to empty space, word word push as index. We are pushing specific character to our word. Yes. And after this while, we are either on the end of the string, or we again reached the empty character. So basically it means, yeah, we don't need to do anything else, because if we reached empty character, the new array would skip a bunch of empty characters and again go and try to get the word, right? And yeah, it seems like we don't need to do anything else. After this while, we will have our words array done with the words ordered in the original string order. And what we can do next is to basically reorder them. Oh yeah, actually this word, no, we didn't put it into our words array, so let's do it. Words push word, not here after the array. Words put if word length more than, no, it should be more than 0. We don't need this check. Push word. And here, yeah, what we are doing is we are word. Remember, let's remind it, word is just array of characters, and we need strings. So we can do this trick, which will convert array of characters to the string. Now we are iterating from the end of the words array. So words length more than 0 minus 1. Yes. Okay, just checking we are still alive. Yeah, we are still alive, and this is good. This is very good. Okay, now we are introducing our result, which is our resulting string. And what we're gonna do, it is not very optimized because there are a lot of like new strings created, because we are doing like this concatenation and stuff like that, but let's assume it's all right for the moment. We are doing result push words I and return result. Basically that's it. Good. Yeah, but also what we should do, yeah, we should, yeah, result is not array, I'm sorry. So result is a string, so we are doing words I, and also we should, no, actually, why do we do this? I'm sorry. We can do actually better. We can do words reverse. Will it work? Now the answer to the question why am I using GS, and again popped out because I can do this. Yes, it will be reversed. Okay, so words reverse, and then we can do words join with this. Yeah, and it should be let result. Okay, let me see. Yeah, we're iterating, we're skipping all empty spaces, adding the index, break, what, empty. Поможи, брат, поможи. Треба допомога. Yeah, and then x++. Yeah, good. Let's try to run. Yeah, and it is accepted. Actually, all the test cases passes. Good. Let's try to submit. But we will do solution with constant space. Yeah, before that, let's actually analyze what is the complexity here. So our index in this while in this whole while. It will attend every possible index in our string only once, which means its complexity O of n, because index will never be the same multiple times during the different iterations. However, we see like 2 more whiles, it's not n times n, it's only n. Because yeah, once index is 0, let's say this loop would move it like 4 index in the forward, 4 index forward, and these 4 indexes will never be we will never visit these indexes again. So this gives us O of n, and this, okay, I think reverse algo should do it in O of n, default reverse algorithm in the JS. So it's n, and this one I think it's also n. So in the end it's O of 3 times n, which is basically O of n complexity, which is good complexity. Regarding the space complexity, what we got here, let's count it. So we have our words array, which is already in worst case it is n, because the words array can be like this, single character. This is O of n, and we are adding this array in the indexing. Then we are reversing. I think reverse happens in place, so it is constant space. And then we are joining to the string, which is O of n again. So it's O2 times n, which gives us O of n. O of n solution. Can we do better? Actually, we can. There is follow-up that we should do it with constant space. So with constant space, it's a bit harder, but still doable. So how we can do it? Actually, in our language, in JS, string is not mutable, but let's say we are doing it with the mutable string, which is array of characters. So yeah, how we can do it? How we can achieve it? Let's just assume we have array of characters and we need to reverse words and remove all the spacing, unnecessary spacing. Actually, let's think about it in a bit different way. What if we would not need to reverse the words, but to reverse a single characters? How would we do it? How would we implement this algorithm? So in this case, let me remove this thing completely. So in this case, we might just forget about words and stuff and just do in place reversing. So starting with index here, and right index moving to the middle, left index moving to the middle, change the characters on both sides, which will give us reverse. We can actually implement this function because we will anyway need it, right? So yeah. So let's say we have index left and index right. These are inclusive indexes. And how the typical reverse algo would work. Let's say we have string as input parameter, right? We can convert it to etc., which is split, like this. This would give us the same thing, but expressed as an array of characters, right? And now, how do we reverse the string? So let's say I have ABC and I want CBA. How do I reverse it? We just we are starting from the left as 0 and right as the length of the string, and we are doing this while left is less than right. We are doing just swapping the characters. So string left equals string right equals string left. Good. And meanwhile we should update the indexes. So right should go from the end to the middle, and left should be going from the start to the middle as well. And that's it. That's how we do it basically. And if we do it, this is what we got. String reverse 0 string length -1. Let me show you what we will get. Good, so as an output we would have exactly fully reversed string. The sky is blue, but it is reversed also with the wording. But if, for example, you would have the single characters, it would not be a problem. The problem is that, yeah, the order of the letters in the word is also reversed. So what we can do about it? Actually, we can go now word by word and reverse the single word back. So let's say here we can see that blue is the word, and we can reverse exactly this word starting from E and ending with blue, which would make us blue again. And we can do it with the same word, basically fixing the order of the characters in the single word. Still we have the problem with the empty spacings. We should skip them, and also we still need to, like, how we can skip it, right? We can skip it in the way that I mean, if we skip the empty spaces, our the place where we are writing would be like one less. So actually the basic algo should be the following. Let's consider this one. Hello world. Yeah, let's say this is our string. What we would get? We would get this one. OLLEH DLROY. After first reverse we would get this one. Yeah, here we are. Yeah. Yeah, I'm sorry. Not this one. Here will be hello, and here will be yeah, exactly. So the order of the words themselves is correct, because hello world should become word hello, which is it basically, but with two problems. First is empty spacings, second the word itself is reversed. So now we should go word by word and reverse the words themselves, which we can do also in place, so maintaining the same array basically. So we can say we can do this, but now the problem is still that we should drop all the spacing here, which means when we are reversing the word and any specific word, we could start writing it in a specific way that we actually skipping all the empty characters, and we only maintain character one spacing character after the word. So let's say we are adding the word and we just put in one character, exactly how it is stated in the task. So okay, now we are on this state that we just reordered the empty string and we have reversed the words. Now we should go word by word and reverse the characters or letters in a specific word, making it this one, and then we will figure out how to omit the extra spacings. So this is our approach. Let's now implement it. Actually, we can leave it. Yeah, now let's implement it. So we reversed the full string. Now as we should do constant space in the follow-up, we can actually maintain the same string that we have as an input. So we are doing pretty much the same. So while index less than s length and string index is equal to empty character, we just maintain this index until we reach the word. Again, same thing happens if index is equal to s length minus 1, s length, meaning we on the end of the string we should break this loop, as we have nothing to do anymore. We reach the end, we should follow up. Now when we are encountered the actual word, so we encountered the first character, we should decide which is the boundary of this character, which means we are doing exactly the same thing as before until we don't reach the empty spacing. Yeah, let's say we are doing something like write index. I will explain a bit why do we need it. So the thing is that there can be this example like ABC, couple of spacings ABC, couple of more spaces ABC. And the thing is that we actually want to make it ABC, ABC, ABC. And the thing is that this index, it would go further by skipping the empty spaces in this while true, right? Or in this while iteration. And it means that we cannot write in place using this index, because when we encounter A, we would like it to be here, as in this string, right? So we should maintain the specific write index, which would actually be the index where we overriding the initial input string. So how do we do it? Right, x++ equals to string index ++ as well. So we're just moving. We are, let's say, at this stage, this is our word, this is our write index, and we're just doing like this. Put in the word. And now what's gonna happen? We wrote it, but it is still reversed. As you remember, it is still like this. And now we need to apply our reverse function to this index. So okay. Yeah, with only write index, it will not be that easy. Yeah, we need to have boundaries, so we need to have this index on D and this index on W, which means Okay, how I can do it? Our right index would be actually the right index, so right one is a direction, so we can say and state that it is right index. The only thing that we still need left index. This left index would be our D. And we should set it here. Left index equals to index, basically. So yeah, let's say our index, we skip these 2 characters, we reach to the D, it becomes our left index, and we are iterating until we reach our right index as a W. Then we should reverse left index and right index, which will make our DLROW as a world, and then we just proceed. No, after we reverse, actually what we need to do, we should do string right index, not right index, yeah, right index plus plus. Right after this word we are adding extra space because we need it. It is explained in our problem. And also, since we already did it, we are doing index. No, actually, index plus plus. Maybe we don't need to. We don't need to. Yes. Yes. Basically, that's it. And after that, what we can do? The last one. The last word will have this empty spacing, so we should remove it because here we should not have any extra space after the last word. We are removing it by just we can use slice 0 string length -1 and then join, put it to the string, and this is what we would return. Oh, I'm sorry, it's a bit maybe hard to explain because it's much better to visualize. I can show you in the solution later on. There is very good visualization, but let's first try. I'm pretty sure it will not work. Let's try. Good, so we are reversing everything. Yes, there is right index, left index. No, actually with this approach left index can be farther than right index. This is not good. This is not good. And this is not good. Maybe after this I can say that my left index is equal to right index at the moment. Yes. Then it should work, I assume. Yes. Shit, due to OBS it's lagging as fuck. Okay, we definitely missed something. Let's see. Index, right index, star index. Okay. Actually, like, yeah, I think I confused myself even a bit, because what we can do here is, let's say left is our index, and after this we can say that right is our can we first reverse and then write it? No, I don't think we can. Yeah, okay, so left index. Okay, I think one bug I found. Since we did plus plus here, now right index not on the right place for reverse. Let's try with this one. No. Yeah, good. Now, and yeah, now we did everything correctly, but yeah, we should slice actually not in string length, but in right index -1. Yes. Yes. Exactly. So I have a very good kind of picture of this. I don't know, I will try to open it. Yeah, there is very good image for this, but I now cannot find it. Solution. Okay, this is very stupid. Okay, I'm pretty sure we can find it on the leetcode itself. I'm pretty sure. So video is it pointers, blah blah blah. Let's see. There should be for sure some visualization. It's very beautiful actually. If you think about and you visualize the algo itself, it's very good. Like, it's very beautiful. It looks very good. Yeah, this is some video, blah blah blah. We don't care. Right? Yeah, we don't care. Well, no. Yeah, very. Oh, come on. Okay, let me do this. Okay, I think I found one. Okay, here it is. So basically, okay, we are starting with this hello world, right? First we reverse the whole string, And during the second loop, during this one loop, we are writing it starting from the beginning of the string, and when we wrote it, we reverse it again, specifically for these indexes. And then we keep moving, doing the same with this word, writing it and then reversing it. And then we just resize the string and removing whatever is left after our right index. And that's basically it. But yeah, I didn't come up with this solution on my own from the first time. So I think this is okay, just to get all one solution. Why this solution is good? Because if you analyze it, the time complexity would be all one still, because we are traversing the whole string only once. But the space complexity, if we don't consider this like moving from the string to array of characters and stuff like that, because this is kind of a JS limitation, then we can basically say that yes, this is constant time, because we are doing every change in place. And that's it. Okay, let's go. We have 3 more. Actually, I'm a bit late. And there are not that many people, but yeah, previous stream until it dropped, it was fucking amazing. We got like 10 people at some time watching at the same time. It was very cool. So yeah, now I have product of array. Except self. So given an integer array nums, return an array answer such that answer I is equal to the product of all elements of nums except nums I. The product of any prefix or suffix nums is guaranteed to fit, blah blah, we don't care. You must write an algorithm that runs in O(n) time and without using the division operation. So basically, we have an array, and there is product of all items in the array. 1 times 2 times 3 times 4. It shall be 24, right? Yes. What should we do for each of the element? We should, on the index of ith element, we should put this product, but divided by the element itself. So let's say product of this string is 24. For this element, if we remove 1 from the product, so it will be 1 times 2 times 3 times 3 times 4. For 1 it will be this. For 2 it will be the product without 2. For 3 it will be product without 3, like this. And for 4 it will be product without 4. So this is for 0, this is for first index, this is for second index, this is for third index. How I can do it without division? Because yeah, I think we can even now think about brute force solution. So brute force solution is simple. We're just doing 2 for loops. Makes I++. And we do the same with J. And now we are actually, each time we are traversing the ith element, we're just doing product on all elements except this ith element. So this would be our product. Our product equals 1. And here if j equals I, we just skip. Otherwise we are doing product nums j's. And this is, where do we put nums? No, we should additional array. Let result equals new array nums. Thanks. Yeah, and we just then put result I it's equal to product, and then return result exactly. Yeah, but it will not pass due to time limit exceeded. Since it's medium question and medium problem, yeah, it will require you to design a more optimized algorithm, which is in our case all when time complexity, which they stated. So this is good. Okay, now how we can do this algorithm? So let's assume that we have this array of numbers 1, 2, 3, 4, 5, 6, whatever. Let's think this way. Whenever we are on some middle item, what actually we are interested in? Like, what is the mass properties of the multiplication and mass properties of product? The mass properties of product that we can put parentheses whenever we want. So it means that this will be exactly equal to the expression without parentheses. So, which means that actually we are interested on the product before some item, so this one, and the product after some item, this one. And this naturally means that we can pre-calculate each product before. So let's say we are in the beginning and we have pre-calculated product of this. No, it cannot do this. Okay. We have pre-calculated product of all elements except 2. Now when we are on 2, we have product of 1 and product of these elements pre-calculated as well. When we are on 3, we have this product 1 times 2 and this product 4 times 5 times 6. And we kinda can pre-calculate all of these prefix product and suffix product before actually we are doing our main calculation. And this will give us actually the O(n). We will show you so how we are doing it. Let's say we have our prefix product, which is new array nums, and we have for let I equals 0 equals 1 maybe. Yes, prefix. And now how we're doing our prefix product, we are starting from index 1 and we are setting 0 index to the value itself. Whatever it is, it doesn't matter, we anyway would need to include it. So we can say that actually iteration on index 0 we already did, because it's the same like 1 times nums 0, it's the same. And now we are just accumulating the product as this. So prefix I would be equal previous prefix minus 1 times nums ith index on nums array. This is how I calculate prefix product. And the same way we should calculate the suffix product. Almost the same way, but we should start from the end, because whenever we are on index 3, we want to go to suffix array on index on index 4. Oh no, sorry, it will not be index 4. Let me, for simplification, put this 2, 3, 4, 5. So whenever we are on index 2 and we are calculating this product array except self, we want our suffix array to answer the question, what is the product on index 3? What is the suffix product on index 3? And it will give us the result, the product starting from index 3, ending at index 5. So this is why we are starting from the end. Same initialization like prefix, but with the element in the end. Okay, this way we are accumulating suffix product, like suffix product, all the way from the end array to the start of the array. And oh, actually we got some comment from Twitch, which is, oh yeah, thank you, just quietly watching and learning. Thank you very much. I hope maybe it will be helpful for somebody, I don't know. Let's see. Now when we have prefixes and suffixes, what we can do is actually to go through our array once more and calculate exactly this thing. And for example, let's say we are on index 2, we just getting prefix and multiplying it with suffix, and that's it. That's basically it. This is how we omit the 2 inside this product, and we just multiplying 2 products without 2. So we have our suffix, which will be, oh, actually, yes. So let's initialize our suffix and prefix as ones. Then if index is more than 1, oh sorry, more than 0, means we can check the prefix of 0's index, which is the first one. Then we can say that prefix is equal to, sorry, prefix is equal like this, and same if I is less than nums max -1, -2 actually. Then we can say that suffix in our case is suffix I plus 1. Output should be in arrays, so we also need to initialize our result. Yes, JavaScript in leetcode by Microsoft Dev Lunatic. Well, what can I say? The thing is that, yeah, my main is .NET actually, but I actually hate array initializing of arrays in .NET. Like now with newer .NET, it's good. You can do this thing as well. But I just so got used to JS that I don't want to. And also one additional feature why I'm using JS for leetcode, because JS, yeah, apparently I have a bit more experience with it than with Python for sure. And another thing, I don't need to go anywhere else to test what will something in JS do, I can just F12 in the same leetcode question problem, and I can do whatever I want and test it straight away. With the .NET, I would need to go to Visual Studio or to open some online compiler, whatever. And with Python as well, I would need to go to, I think, to my terminal or whenever I have Python, and then test and play with it there. Or like play with it in the leetcode, but this is the even worse option, right? And I think like with the JS syntax, I actually like it more than Python, for example, because yeah, it seems to me more readable. I had experience with writing Python code. I was working a bit on some LLM shit. If you know, you can Google Llama Index. This is the library for LLMs. And I was writing backend for it, like to be able to call endpoint, which would go to GPT and ask something. So you should be using assembly interacting with registers. No. This is not what's gonna happen. If you go to interview at Amazon or Google and you start writing assembly, this would be two minuses. First, you will not be able to solve the problem in time because you have like 30 minutes maybe for problem, maybe 40 max, because other 10 minutes for behavioral question and other 10 minutes for your questions. And this is a red flag if you don't ask your questions, so you should use these 10 minutes. And for 40 minutes, it might be not enough to solve in poor assembly, right? And yeah, and also it will be a red flag that yeah, most probably not that many people are actually understand the assembly, right? Yeah, so that's why JS. Let's anyway proceed. When we have prefix and suffix, now what we can do, we can just multiply prefix and suffix and put this as our as our result. Yes, exactly, and then we can return result. Yes. Yeah, let's see. Okay, I think this one should be -1, yes. Yeah, let's simplify this. Not needed actually. Did I copy it? Yes. Let's try to run. Accept it. Let's try to submit. Bingo. So if one use assembly in interview, the interview should resign. Thanks for advice. Okay, thank you. Okay. So yeah, this solution works, and apparently it's not n square anymore. We have actually as signed, I hope I pronounce it correctly, as signed already answered in comments, it's all 3 times n. Why? Because we are iterating over the all nums once, second time, and then third time, which gives us 3 times n. But since it's big O notation, we simplify it to n, and eliminating all the constants. So this is time, and our space complexity. Actually, we have prefix array, which is length of n. We have suffix array, which is length of n as well, and we have result array, which can be kind of omitted. If you can ask your interviewer if you can omit it or not. If not, it's also n, because we are accumulating the result, which gives us also n O 3 times n, which in the end gives us O times n. So this is O n solution. So yeah, as a follow-up, let me check. So follow-up, they wanted to do constant space follow-up. Constant space follow-up would be interesting. Like, it's already midnight. So I'm not sure. Okay, let's do the follow-up. Fuck it, let's do the follow-up. It's midnight. 5 viewers. OBS still didn't throw me out, didn't reconnect, which is good. Okay, I know how to solve this problem mathematically, but in coding. Where are you from? I'm from Ukraine originally, but now I'm staying for 3+ years in Prague, Czech Republic, since I relocated. Yeah, relocated due to offer from Microsoft. That's how. So yeah, we have space complexity as O(1). Also, let's try to think about of constant time solution. So actually, whenever we on the some middle point in our array, 0, 1, 2, 3, 4, 5. Whenever we, let's say, on fourth index, do we actually care about prefix that is stored on second index, first index, 0 index? No. Whenever we are on fourth element, we actually interested only in product of whatever was before, right? Whenever we are at index 1, for example, same thing happens with the suffix. We are not interested what suffix was for fifth index, for fourth index, for third index, and so on. So we can leverage it and basically don't maintain the array of prefixes, but to maintain only one prefix and maintain only one suffix, in a way. You need one array of length n+1 to solve it. Okay. Well, okay. I don't think actually I know the solution that can be done with constant space. Well, constant space in the sense that actually we are using the result array. So what we can do, let me drop everything. So if we don't count this result array, if you don't count it, it can be in constant. If you count it, yeah, it's O(1) space still. But it's not 3 times n, it's just O(1). So let's still implement this solution because they specifically mentioned that can you solve problem constant extra space complexity, the output array does not count, which means this result array does not count. How we do it? First, we are reusing result array and we are filling the result array with the prefixes. So for yeah, so result 0 equals nums 0, that equals 1 unless nums length c++. And then we are doing this I-1 times nums I. Currently our res array is kinda Can you hack Insta account? Okay, this is the best question. I think around 5 people during my last 6 year in career already asked me, like literally five different people asked me, can I hack the Instagram account? Guys, usually you cannot hack Instagram account because Instagram has like bunch of very skilled and clever developers that already forecasted what you can do, and usually the only thing you can do is social engineering, but also with the technologies like two-factor authorization and stuff like that, you cannot even do proper social engineering because you would need to have a lot of stuff from the user that you can trick, like his phone, his email and stuff like that to confirm everything. So very hard to do, very hard to do. So yeah, and if I even take this, no, sorry, I think on YouTube I cannot say it. I cannot say it, yes, so sorry. So no hacking, I strongly against, no hacking Instagram accounts. Please don't do it, I strongly against. Okay, on the Twitch, there is one person who is commenting, lol, the first solution brute force was OVAN. Yeah, for the space complexity it was OVAN, I agree, this is true, but the problem was that it got time limit exceeded because this medium problem requires time complexity of n. However, space complexity was of 1, our time complexity was n squared. That's why it kinda not good. So let's proceed with our solution. Our result actually has prefixes right now, and now we will be modifying the result array in some way. So we already have prefixes, now we need to maintain the suffix, and we should not use array for this, we should use some single variable because we want constant space, right? So how did we do suffixes before? We are starting with nums length -1, right? Oh shit, let's I equals nums length -I, exactly. I bigger or equal 0, I minus. Now let me put our suffix as 1 because we're gonna do product, right? Thanks for the solution, gonna apply it soon. Okay, no problem. And now we're gonna maintain our suffix and still using the prefix before. So let's say we are starting from the last index, and for last index we just do this. Our suffix will be 1, which is totally fine for us. It will not change our product, and as we know that our result is already prefix, we know that result -1, the previous one would be the prefix, right? Would be the prefix of everything from the start array to the index I-1, which is exactly what we want. And what we should do right now is to update our suffix with the current number, so that when we moved back to the 1 index less, the suffix would have up-to-date value. So we are kind of maintaining suffix on the fly, and prefix we are using previously calculated prefix from the result array. And that's basically how it works. Yes, and also I think, yeah, there is one problem because when we hit 0, I-1 would give us undefined. So for yeah, and yeah, we actually even don't need to do it. We don't need to do it because we already. No. Yeah, maybe we have to then res0 would be suffix. Yes. Let's test this out. Let's test this out. Good, accepted. Good. That's how I did it with constant space. But I should be greater than 0. Yeah, exactly. Right now it's equal than more than 0. I'm sorry, more than 0, because yeah, otherwise we would hit out of range exception. And for 0 index, we are doing it after the iteration. So this solution has time complexity. We have basically 2 times n, because we are iterating through the nums twice, right? And space complexity, it would be, if we count output array, it will be n. If we don't count, it will be constant time, because we are doing in place operations. Good. So increasing triplet subsequence. Oh, this one is very interesting. Or each sorry, very I'm gonna apply it soon, but it's or each project should have its DB context. Sorry for being out of context. Sorry, caramel carrots. I'm sorry, I didn't get the question. For each project should have its DB context. DB context, are you talking about entity framework? For each project should have its own DB context. Well, it depends how you build your app, but yeah, can be. Good. Good. Now, with this solution, so we are given integer, and we should find such triplet so that indexes are always sequentially increasing, and also the values. So indexes are strongly ordered and values are strongly ordered as well. If no such index exists, return false. Follow up, could implement solution runs O of n and complexity 0 space. So first thing, like the naive approach, the most brute force approach would be which? We are trying to find 3 numbers that fulfills these 2 criteria. How we can do it? Very easy, pretty much easy. But complexity will not be good. So how we can do it? We can just iterate over everything we have and just check whether this criteria is maintained or not. So we can have our I, j, and k. Let's put it the same way. So I, 0, nums length, I++. Next one, we are initiating j, which should be strongly higher than I, which means it's I+1 always. J less than nums. Okay, actually, since I starting at the start, the last I on the triplet should be 2 indexes before. So I started here, and we are checking triplets like this: 1, 2, 3, 2, 3, 4, and 3, 4, 5. When I on the 3, we should not try further, because if we try I 4, j would be 5, and k will be like out of range. So that's why it's length minus 2. This one nums length minus 1. jj++. Good. And the third one, let k equals j plus 1, because it should be strongly more than j. And k in our case should be up until the last element in the array, right? And now we are checking if nums I less than nums j and nums j less than nums k, we basically return true. Sorry, yeah. Otherwise we return false. This is constant space solution, right? But it's n times 3. Not n times 3. I don't know how to say it in English. It's n times n times n. N in the wait a moment. To the power of 3, I'm sorry. Yeah, it will be n to the power of 3. N to the power of 3. So this solution should work, but we will hit time limit exceeded, because yeah, actually they ask us to implement, or they don't ask us explicitly, but this is medium problem, it will require you to implement something better. So what is the first step to optimization it? Use two variables, greatest and second greatest. Now try. Yeah. Good. Easy this one. Need a hint? No. Actually, I already solved it some time ago, so I kind of know this solution. But yeah, this solution with two variables, greatest and second greatest. This is the thing that I didn't come up with myself, because I'm very bad in leetcode actually. So yeah, let's go step by step so people understand the thinking process. So first we have n times n to the power of 3, right? How we can eliminate one of the fours? For example, we can eliminate k, like this 4. Basically, we can think as this, like how we can somehow memorize something somewhere, and based on second problem that we previously solved, we can think as this. If we found two nums I and nums j that are already fulfilling our requirement, what we should do, like what we should find? We should find some number starting from index j to the k that is greater than j. So how we can do it? We can do exactly the same thing as we did with the suffix, but instead previously it was suffix of product. Now we can maintain the suffix as a maximum number so far, which means in this case 5, 4, 3, 2, 1, our suffix array would work like this. This index at 1 would have number 1, this index at 2 would have value 2, this 3. This is basically the suffix array itself. Let's see this one. So this will be 6, 4 is less than 6, so at this index it will be 6, this will be 6, this will be 6, this will be 6, everything will be 6, because suffix array at any point to the right there is bigger value, which is 6. So with this thing, by memorizing this suffix, I'm trolling you? No, I'm not trolling you. Just not that many people are that clever. Actually, leetcode is my weakest point. I'm much better in system design and other like fank interview types. So for me, leetcode, like, I very appreciate when people are doing it sequentially, step by step, explaining me the thing. Okay, bye bro, need to prepare dinner. I don't have GF at the moment. It's okay, man. Don't worry. It has also pros and cons. So enjoy your time alone right now. When you would have girlfriend, you will not have that time. So okay, I think this would be the last problem, and I would go as well. So actually, how we can eliminate this 4? Pretty simple. We can memorize the suffix, which will give us the maximum number from some index up to the end of array. And with this one, we will eliminate this if. So let's do it. Let's start our suffix. Length. Good. We are initializing array. minus 1 equals nums length minus 1. Exactly. And now you're starting from fucking bullshit. Oh my god. Okay, it seems like we are alive. I just got the reconnecting of OBS again. I hate this. Okay. I hope we are online. Yeah. Yes. God's sake. Good. So we are maintaining a suffix and suffix I and nums I. Should be previous suffix, so -2. Exactly. So now we can answer the question whether starting from the index j plus 1 we have something like what is the maximum number that we have starting from the j plus 1 up until the end of array f, and if this value is greater than j element at index j, we can say that it is true and we can straight away break. So we are eliminating this 4, and instead of nums k we can just check suffix j plus 1 and right, yes, but in this case yes, so this should work. Yes, but it's still not that great because we just converted n time to the power of 3. We converted it to n to the power of 2, which is still not enough for this problem, right? So how we can improve it even more? We can actually try thinking the same way like we thought about suffix, and we can try eliminate this 4 with the I index. So we can actually maintain also the maximum, or sorry, not the maximum, the minimum number as a prefix, because we need to know that there is something before j element that is less than j, strictly less than j. So we can do exactly same thing. Let prefix equal new array nums length prefix 0 equals nums 0 equals 0 is actually 1, and then we are calculating our prefix as the minimum possible value. So mass min which is prefix I minus 1 and nums I. Yes. And now with this one we are eliminating actually the outer loop. And now we have this only loop with the j, and for the ith element we are just checking the following, that the prefix j minus 1 is actually less than nums j. And that's it's basically this should give us O(n) time complexity. Oh shit. J equals 1. Yeah, now this problem would pass. Exactly. But we can do even better solution. And this one is a bit tricky. Maybe I should explain it with the paper as sign proposed. So the optimized solution with O(n) space complexity is the following. Right now, let's analyze also. And this one gives us time complexity equal to O big O n times 3, because we have first for loop, second for loop, and third for loop. And with space complexity, we have O times n, O of n times 2, because we have extra space for prefix and suffix, which is length of nums. This was actually converted to O(n) because this big O notation, and we are skipping the constants, right? Now the problem asks us to do constant time. So the problem wants us to do constant time solution, but still with the complexity of n. So let's drop it. Actually, another solution is very interesting. I didn't come up with it by myself. So what we are doing, we are maintaining two numbers. First infinity, and let second infinity first. So, and we are iterating over all of them. And basically what we do, first we would like to find as low as possible first and second number with the following criteria: that second should be bigger than first, also strictly same as explained here. So basically what we are going to find, I and nums j, nums I and nums j. So if nums I less than first, we are assigning first equals to nums I. Else if nums I less than second, we are assigning second as nums I. If the number is greater than first and greater than second, we found our triplet. Return true, and here we return false. Since it's one iteration, we can just say that it's O(n) time complexity, and for space complexity it's 0 constant time, because we are using only two variables. Oh fuck, it's wrong answer. What? Okay, this one I don't know, like, how come? Wrong answer. Okay, this is interesting. This is very interesting. I'm not actually sure why. It should be working, but okay, I'm not sure. Let's check. Let's actually check. So if now it's less than, let's run it. One. Okay, so when it's 111s, okay, now it's less than first. Yes, we are assigning first, and it's less than first. No, less than second. Yes, we will assign first. Okay, since we should add equals, because in first two iterations, first would be 1, second would be 1, and for the third one is not less than first, so we go here. 1 is not less than 1, so we go here and return true, which we should not. In this case, we should just reassign if it's equals. Should still work, by the way. Yeah, just submit. Good, yeah, now it's good solution, quick. Let me show them why it is working. So let's say we have this exact triple, so 215, 215, 046, 046. This is the last problem, by the way, guys. So let's say we have our first and second index. So by default they are infinity, so they are like extremely high. And first we are trying to go and we see the 2. 2 is less than infinity, so we assign the first index here. We iterate over and we see that 1. 1 is less than first, so we are assigning first here. This first we are removing. Then we receive 5. 5 is not less than first value, which is 1, so we assign it to second. Now at this point we know that we should find something in this area that should be more than 5. Just keep that in mind. We iterate to the 0. 0 is less than 1, so we are assigning first here and remove it here. And this is the first thing that got me very confused, because in the problem description these indexes should be ordered. So first index should be strictly less than second index, and here we are putting it to 0 and it becomes like bigger than second index. What the fuck is this? It wasn't actually that natively understandable for me. But let's just go through and I will explain you later why it works. We got to the 4 and we are putting second index here. Now the order is maintained. We got 6, and 6 would be our third index because it's more than 0 and 4. Now let's run over another example. What if the how to thank you. This is what I wanted. Now let's assume that this one is 6 and this one is 4. It still should return true because we have 1, 5, 6, right? These 3 guys. But now we are in a situation that first index is higher than second by order, which should not be the case. And we still encounter 6, and 6 is more than 0, 6 is more than s, and it means that it is third index and we return true. But how we can return true in the state that first index is higher than second index? This is the case that actually the tricky part that I didn't come up with, that this first index is kind of temporary thing. So it's temporary here. It is needed for the next iterations, for the future. We can think that if we don't put this first index here, the previous first index is 1. The important part that we didn't move second index, and we always maintain that first index is less than second index, and second index we didn't change, it's still 5, and we just need to find something that is more than 6. Oh, sorry, more than 5, which is 6. And however, current first index on 0 and order is not maintained, actually if we reverse this step back, order will be maintained with this one, and basically nothing changed if we moved this index and that index. Yeah, I know it's not that intuitive, to be honest, and I also didn't find it intuitive when I was searching for the solutions and saw this solution. I was like first like thinking like what the hell is this, why it's working. Like I strictly remember the order of indexes should be the following. So yes, but I think not everybody can come up with this kind of smart solution, and I also didn't come up with it, which is kind of okay, because yeah, I accepted that I'm very bad at leetcode questions. I'm very bad at it, and I want to be better. That's why we are here, and we are solving, we are training, we are improving ourselves. So yeah, basically that's it. This is our last problem. I think everything for the rest we will be solving next time. I will try to solve my disconnection from the OBS. I will try to solve a problem with the I will try to solve the problem with the freezes and stuff like that. I will review. Let's see how it goes. It was my first stream in a very long time. I hope we will do it next weekend as well. Thank you so much for the attending, for the commenting especially. I very appreciate it, guys. I didn't expect actually to have even like single viewer, to be honest, but somehow we are all here. Thank you very much, and yeah, see you guys. See you. Bye bye. Please subscribe to Telegram and Instagram channel, because I'm posting updates about next stream, topics, articles, stuff like that. Also, yeah, check my personal blog where I'm describing different interesting stuff, and I will be also reviewing leetcode questions there as well. Okay, thank you so much for attention, and see you guys. Bye bye.